everyone. Welcome to our Stories Behind Products number 7. So if you're like me and you sit long hours while working, you would know that our bodies are not designed to sit, and designing a good chair has never been easy. So my name is Zoya Demirbilek, and I'm a professor of industrial design at UNSW. I welcome you all from the beautiful Wiege country where I live and work. And I'd like to acknowledge the traditional custodians of this unceded land. I would like to pay my respects to elders, both past and present. And today is Wellness Day at UNSW. And this evening, our presenter is Carlo Shayeb. Welcome, Carlo. It is lovely to have you here. Carlo will...
for the invite.
Yes. Carlo will be presenting the story of C-Motion, an office chair he designed while working at Sedus, a leading German manufacturer of office furniture. So Carlo is one of our 2005 alum of the UNSW Industrial Design Honors Program. His graduation project, actually, I have an image here. There we go. His graduation project was a chair for musicians. And then one story I recall when Carlo was a student with us is that he bought himself a second-hand Wilkhahn office chair. And then he went to the Wilkhahn factory in Sydney to get it reupholstered. And that was the beginning of his relationship with that company and with designing office chairs. So during his studies, Carlo worked as a designer for Wilkhahn Asia Pacific in a cross-functional role, including custom design solutions, interior planning, photography, and exhibition design. And in 2006, he moved to Germany and began to work at Wiege, a sister company of Wilkhahn, designing products outside the corporate office sector for brands such as Lamy, Tonon, Rolf Benz and Loewe. And during this time, Carlo worked on his first complete task chair, the On chair. And I have an image here too. For Wilkhahn, a chair affording a unique three-dimensional dynamic sitting experience. And you can see here Carlo modeling the chair. So after completing that chair, Carlo joined ITO Design in Nurnberg, working with international companies, including Haworth, Herman Miller, Kinnarps, Profim and Sidiz. And Carlo joined Sedus in 2017 as an in-house product designer, where he developed 4 product families, including the C-Motion chair. And he currently works in product innovation, design, and sustainability at Vitra in Basel, Switzerland. So now I will hand it over to you, Carlo. Over to you. And I need to
Great. Thanks for the intro. I'm really happy to be here, to be able to share this development story for C-Motion, which is quite unique for me, because usually task chair developments take a very long time. But in this particular case, it was actually very fast development. So yeah, I'll just share my screen and what the requirements and goals were for the project. Then into the concept phase, give you a bit of a look at how the concept developed, then the design phase, and finally the construction phase, and look at some of the production processes involved and the different stages there. So basically, C-Motion, the goal from the beginning was to have a very simple task chair, so a chair for working at desks, but most task chairs, they have these huge mechanisms underneath and they have a lot of adjustments, which make them highly ergonomic, but most people don't know how to use them. And that's a big problem, because if you're sitting on a chair which is adjusted incorrectly, then you're not benefiting yourself. Especially with a lot of these co-working zones and hot desking situations, people don't really even think about adjusting the chair. They just sit there. So the goal with this particular chair was to give the best kind of comfort you could to the largest percentile of people, but at the same time, keeping the chair really simple. We also were keeping in mind this kind of cross-functional environments where teams are switching, like programming environments, people working very close to one another. So the chair also had to be quite lightweight and quite open. And obviously all the different EN requirements, there are different types of requirements that we wanted to achieve. And there was an online goal. So the chair was to be one of the first chairs to be sold online at by Sedus. So that was also kind of like a goal, having fit into a particular box size. So for design, I think the first kind of step was just to map out all these different requirements and maybe also start thinking about the different possibilities that we had for each component. So if we're looking at the backrest, and I think the seat and the armrests, they were the main components, and just trying to kind of break down all the different things that needed to be kind of worked on. Even though the chair is one whole, you kind of just break it down to begin with to kind of brainstorm possibilities. We also had some requirements for the upholstery, so it had to be exchangeable to make repairability and maintenance a lot easier, especially for facility managers or for people, working at home. Just a very customizable kind of piece of furniture. So that's, basically all the requirements that we had. And based on that, we dove into the concept phase together as a team. It was a really team-intensive process at the beginning, together with our engineers. And we were looking at how to achieve the best ergonomics with the simplest kind of possible structure. And obviously we wanted to get away from having a mechanism, because a mechanism under the chair requires you to adjust. So we wanted to come up with a system that was, a weight activated system. So basically you just sit on the chair and the chair reacts to your own weight, and you're able to basically get the best kind of comfort and movement based on your weight. So we started off with a lot of mock-ups, and this had to go really quick at the beginning. I was just starting out at Sedus. I think I was in my, 4th month, and we received this challenge from top management. And there were also some potential concepts from external designers. So we were kind of also in a bit of a race and a competition that we didn't want to be in, but that was the situation. And the team really came together, and we came up with all these different possible kinematic solutions. And what you're seeing right now are like we didn't actually have too many of them. We quite early on got to a solution which was quite promising. So what you see here are like iterations of that. Working together with engineers, our engineering team, we kind of came up with a system which is similar to a parallelogram. So basically, there are kind of either 4 points or 2 points, and the rest are kind of simulated points in order to create a movement. And we just played around with all these little models and tried to figure out which ones give us the best results. And the kind of like these kinds of small models that we have here. So basically gives you just a sense of how the movement could be. And this is practically very close to the final movement that we had, which we really liked, because we didn't want a lot of weight activated mechanisms on the market that were more or less like a box under the seat. They lifted the seat too far up, so it created a lot of pressure. And we came up with a solution that was super comfy and still didn't create that pressure in the front portion of the legs. So you can see here, basically we had this parallelogram principle with 2 turning points, the back, but in the front, the material flex, these kind of 2 bands that go out towards the front of the seat. And they're working together within the system to create this movement. So we didn't require any kind of springs or anything. It was all just this material spring that was assisting in the movement. And you're kind of working against your own weight. So when you lean back, you're lifting yourself up. So, regardless of what weight you have, you're able to kind of get the best adjustment automatically without having to, turn any dials or anything like that. It does have some caveats that, for example, if you have a very high torso or your proportions are slightly different, it may react differently. But I think that was a good compromise, in this particular case. So yeah, we went into like a one-to-one prototype. Once we had small mock-ups that we thought were looking good, we kind of built it one-to-one using the workshop downstairs, and just milled out of a similar kind of polymer these two spring elements, just to get a sense of how it would work, and also to be able to experiment a bit with the movement and shift the turning point slightly to get the right proportion. So you want to kind of synchronized mechanism usually has a certain amount of degrees recline in the back toward compared to the seat. So we wanted to keep that or design it so that it's as comfortable as possible. And that's us in our Denkraum. So actually the building we were in had 2 levels, but there was a secret level at the top, which nobody knew about, which was great. It was the kind of the design room where we had our materials and photo shooting studio, and it was super cool. You got there through this staircase that many didn't know about. So it was a quiet space, and you could also eavesdrop onto the meetings downstairs. So it was pretty cool. So we use that also for a lot of the prototype testing and building things together within the team. So yeah, that was the first rough prototype that we had. We reinforced the spring a bit with steel spring to adjust the amount of flex a bit, but we were getting towards a solution that we felt really comfortable with, and that we thought was the correct solution for this project, because really it showed the potential of being just 2 parts for the whole chair, so the backrest and the seat. We didn't yet know if we could combine the seat and the spring element together, but that was the hope. And it could have been a complete chair basically out of 2 parts. In parallel, started thinking about the chair structure. So how could the chair be built? What components, what materials. So some initial ideas were about having a mesh back, for example, and also how to dock the armrests onto the chair, which is quite tricky because we wanted to have a very lightweight kind of structure, but at the same time, we knew in the back of our heads that you have all these norms and some pretty terrible tests that the chair has to go through. So we wanted to try to find a balance between those two. The first design concept, which was just roughly modeled in like sub-D modeling, not parametrically modeled, just we were really under time constraint. So showed that, the chair could be built basically with the heart of the chair being this kind of spring element to which the backrest is connected. So it's basically those 2 parts. And if we were able to create or mold it together with a seat, it would be basically the whole chair. In this case, we also had an additional seat shell that would be attached. And that's basically the whole chair. So that would provide you with the movement and everything. And the height adjustment being the only adjustment that you have to make in order to get the right kind of position. And then obviously being able to attach the armrests, that was something that we wanted to have as an option, and also make it as easy as possible for the end user. So those were the first design concepts that we went in to management with, and we felt really confident, and I think we were quite lucky. They were 100% kind of behind us for this particular concept, and from an ergonomic standpoint, it was also better than what the competition, the external competition. So we were super happy with that. So at that stage, we say like the design phase starts, because this was just based on the technical concept that we had, and you could say that final concept was kind of designed, but it wasn't really. It was just sub-D modeling, and there was a lot of details missing. And so we started the design phase, looking at all the different possibilities, so possible structures for the back, different materials we could use in order to achieve the comfort that we wanted to, Yeah, a quick note, we initially thought about mesh, but for the price range of this chair, that was unfortunately not possible. So we had to kind of look at different possibilities without having, yeah, the additional steps of using a mesh to attach to a frame that was, from a cost perspective, too high. So we were looking at co-molding solutions, or the possibility of having two separate structures, so having a frame and then maybe like a flexible membrane. And we were also using, yeah, just simple augmented reality to compare the product. That saved a lot of time. We actually didn't build that many design models for this project. We went straight into prototypes, which I'll show you in a bit. So augmented reality kind of helped get a sense of proportions and size compared to the other products at Sedus, without having to build these design models at each stage, because it was going really fast. It would have been almost impossible to do that. Yeah, that's a small model I showed you. So we kept on kind of refining the turning points, just small changes, and maybe making a slightly bigger model, because then you're able to measure angles. But yeah, this was kind of like combining design and functionality and trying to get a sense of what's happening. Is it working exactly like the one-to-one scale model? Yeah, so that's Kurt, one of our model makers, and also I would say he's got a lot of patents under his I don't know, under his belt or under his fingers. He's basically really talented with his hands. He's able to mock up things really quickly, and if you have a technical idea, he's able to come up with a solution. So he was quite instrumental to this project, and yeah, he was building the first design model here, so non-functional model, just to get a sense of the size, and also start to explore the upholstery with these parts, because as I'll show you, the upholstery was actually one of the trickier parts of the project, surprisingly. So yeah, we were still kind of exploring different backrest structures, trying to figure out, what kind of structure would give us flexibility, but also at the same time, the aesthetics of the chair. I don't talk too much about the aesthetics, because it really was derived from the function of the chair, and really eliminating like all unnecessary kind of material. So we were really trying to reduce it and make the chair as efficient as possible. So the design kind of came out of that. Yeah, one of the I think later design models, I think it was the second, maybe the only design model with this kind of back. And we had all kinds of issues. I didn't know how to use Grasshopper or any of these new programs for creating patterns. So this was a iterative, hand kind of painstaking process in CAD, and yeah, until we kind of found a pattern that could be reproduced, and then playing around in SolidWorks at the time to kind of create a smooth pattern that wasn't that much fun. Yeah. And then, yeah, we finally came to made the decision to try to create the back out of a single part. So the whole time we were thinking, okay, you have this frame, you have this flexible material, and then we're like, okay, but would it be at all possible to kind of combine it and have it in one part? And what would that entail? And luckily, we're working with some really good and technically competent suppliers in Germany. And one of the technologies that they have is called mono sandwich. So it's basically injecting two plastics after each other. And in this case, it's a polypropylene. So you have like a polypropylene core, which enables you to get the stiffness that you need where the mechanism is, and on the outer sides of the frame. But then at the same time, being able to inject just a pure polypropylene to get the flexibility and the movement in the top part of the backrest. So it's quite a complicated process, but they've managed to do it in such a way that they can actually control where the different materials flow. It's a bit of trial and error at some points, but it works really well. And that enabled us to basically combine the back into a single part. And this was a laser sintered part. So it's 3D printed, 1-to-1 scale in a very, I would say material which highly represents polypropylene with this glass reinforced part or midsection. And yeah, we were able to build that into the first kind of prototype, which was fully 3D printed actually. We only 3D printed prototypes, which was quite cool, very fast and efficient, and enabled us to test the chair really quickly and not have to wait for, you know, milling or combined kind of activities that usually would be in the development process. Yeah, this was looking at some arm pad variations. Again, we needed to have something. We didn't want to use glue. We wanted to have these parts as easy as possible to disassemble. So we were looking at click systems, how to be able to click the armrest on easily, but also remove it in case something is damaged. So yeah, these were just an exploration of the arm pad itself, which had to be clipped on, and also made sure that there were no kind of the tolerances were quite tight. And that's the first fully functional prototype that we built, completely 3D printed, except for the seat pad or the seat shell that was milled in-house, but the rest was laser sintered. And yeah, we were able to use this to start also looking at the upholstery development, which was a really important part of the chair. That's Klaus, I'd say one of my favorite engineers. He was, yeah, instrumental as well in this chair, because most engineers are kind of shying away, or they want to add material, make things thicker. I think he was kind of pushing even me into a direction which was thinner and more lightweight. And yeah, he's not afraid to kind of explore these, especially, you know, in this kind of case. His reputation is on the line, because a lot of the engineers, they're quite scared. They have to you know, bear the brunt of management, or if something goes wrong with the tooling, a lot of it lands on their shoulders. So yeah, you have to really hand it to him for being really open to this idea and yeah, pushing it even further. So yeah, one of my favorite engineers. Yeah, so these were some of the tests that we did in the test lab downstairs. There are all these machines and instruments that we use. The standards have shifted a bit over the years, and so there are different kinds of testing rigs that we have. Some of it is a bit complicated to position, but in this case, we were only just measuring certain things like the S point. There's a certain point where the lumbar is that has to be measured from the seat pan. And if you have a foam, then it's the compressed seat foam. So just all these kind of measurements that are required to make sure that we're in the right range. And there are no surprises for us further down the road when we get it tested externally. And that's Pepone, Peppo from Sardinia. He's the upholstery master at Sedus, and taking his first critical look at the backrest and trying to think of how we can upholster this, also with the possibility of being able to yeah, take it off easily. So it has to be exchangeable. The idea being like a mobile phone cover, you can just pull it off and attach a new one and be able to clean it, or in cases of damage, just completely replace it without having to send the whole chair back. So yeah, this was quite a challenge. And so that's just yeah, some images of the first functional prototype complete with the final armrests. Oh no, not quite the final armrest, but yeah, very close to the end. And I think at this stage we're also presenting the chair internally and getting people to sit on it and give feedback regarding the movement and yeah, the overall feel of the chair. So yeah, the construction phase, we worked very closely with a supplier which built, you could say, test tooling. So because these springs in the chair are super important to the chair, we had to make sure that they, first of all, were made out of the right material, but that they also didn't deform over time, that there was the right amount of water content is really important. I know from experience, like sending things down to Australia, sometimes the humidity levels or the temperature can have a big effect. I remember we had these honeycomb tables that we sent down once, and that didn't go quite well. So there's a lot of things that are really plugged into the materials, so you have to get that right. And investing in test tooling, like in this case, was really important. And we were able to build these left and right kind of arms individually. So not build the whole tool, but just build each one of these, each segments individually, and then click them together in order to be able to test different types of materials. What you see right now is like the bath, basically, where we cooled up the parts after taking them out, because we weren't there for a very long time, maybe 2 days that we spent at the supplier. So we wanted to kind of inject as many different types of materials to get a sense of where we were heading. And then obviously building the chair as quickly as possible. In this case, we had like a steel plate that was connecting the two spring arms, and being able to test the chair to see how it works. At the same time, also discussing like tooling. So you can imagine this under section, the heart of the chair is quite complicated. You have to be able to create this kind of spring, but at the same time, you have to attach a seat, and at the same time, you have to be stiff enough, rigid enough, where the gas lift is being connected. So there are all these different kind of requirements for this part, and also being able to mold it and have no kind of variation in the materials. So that's really tough. And that was part of the long-term discussion as well with the supplier, as well as the backrest, the mono sandwich. It looks quite easy, but I think the challenge was really how to inject the material, where to inject it, and in order to get the material types where you want it to be. So now back to some of the upholstery work. So in the meantime, Peppo had maybe third or fifth iteration. So we were exploring using a mesh on the back of the backrest in order to show some of the structure of the back, and also to increase breathability. And for the seat, we were also exploring different kind of materials, such as 3D knits or just more elastic materials, so that it's easy for the customer or for the end user to apply it. Also working with a knit supplier for, there were two variations of the backrest. So there was, we wanted to be able to use all the standard fabrics at Sedus, or most of them. So depending on the customer, if they want a particular kind of fabric, you can combine it. At the same time, we were working on a special completely 3D knit upholstery solution. So this here is for the standard fabric version, and we were working on this 3D knit for the back of the backrest. And this is the 3D knit. I have like a sample of it here. So basically, what they're able to do is knit multiple layers all in one. So at the moment, you have like one layer here at the back, and 3 layers, including this film material on the front. So it's really quite crazy that they can knit all these layers at the same time and create this kind of cushioning effect. So you don't have to have any foam or any kind of additional material in there. It's all done in one part. And then, you're able to basically attach it to the chair. But yeah, you can imagine it's quite difficult to get the right fit, especially because the backrest was tapering, and the knitting process, it goes in stages and different layers. So you have to kind of make sure that there are no kind of weird transitions. Yeah, and that's an overview of some of the different seat upholsteries that we tried for attaching. So using 3D knits, having Velcro, having sections of the seat with more of a flexible material. Yeah, but most of those didn't really work because there was too much movement in the seat, unfortunately. So we needed something that was a lot more fixed. Again, more like a mobile phone cover, which really clicks on. So and we ended up going into a more of a molded kind of solution. This is Kurt, also working in the model making workshop with one of the spring elements, shaving off some of the material. I think we still wanted to have or improve the movement. So we wanted to decrease the amount of movement that was going up in the chair and have it more going back. Maybe I can share a quick video. So you get a sense of the movement of the chair. I've only showed that in the model, but so you can see here it's kind of like rolling backwards, and it does go up slightly, but it's because of the waterfall in the front edge, you don't really notice any pressure. So it's like that movement that we were really trying to get in the end. Exactly, yeah. And some of the colleagues in the test lab, this is where the brutal tests are done, 20,000, 30,000 repetitions, sometimes even more, depending on what tests we're trying to withstand. In this case, it was, I think it was the BIFMA test that was being done on this chair. So I'm not quite sure how many repetitions, but it runs for days, and sometimes it looks really painful for the chair. But yeah, then it gets accredited, and we have kind of a report which we're able then to say, okay, we've achieved number of cycles with a certain number of newtons, and that helps us then go to the TÜV, or there's different kind of bodies in Germany that then allow you to test the chair at their facilities. Obviously costs money, and you have to take the products there. So having this done in-house helps speed up the process. Yeah, so the first parts are now coming out of the tools, and kind of like building the first 0 series chairs, you would say, just to get a sense if everything is working. There are always like little problems with the first mold. Some things don't work, or maybe the tool shifted slightly, or something is happening. So you have to make sure that you have to work through all these problems. And we also were working towards an Orgatec release. Orgatec is like a furniture fair in Germany that happened before Corona every 2 years. I think this year is the first time since Corona. And that's where a lot of the office furniture products are presented. So yeah, that was kind of like our deadline, and we had to work towards that. Also working with our logistics team and packaging team to figure out how the product should be packaged to be sent for easy transport and for online sales, and that it's also easy for the end user to understand how to put the chair together. So that was part of the process. And here we kind of built a jig to test the spring force to make sure that the parts are coming out of the tool functioning properly. So we had kind of a jig just to assess, every 50th mechanism that was coming out at that point to make sure that they were all consistent, because consistency is really important for this this mechanism type. And then also setting up all the jigs, or the preliminary jigs in the factory. So also working with the factory personnel who are going to assemble this to make sure that it's as easy for them to assemble as possible, that there are no problems, that they can go through their shifts as comfortably as possible. So all kinds of jigs are built for attaching different components. In this case, it was for the spring element. So there's a bit of a pre-tension in the system. So the spring would be positioned properly by the jig, and then you're able to attach the backrest, and then yeah, with 4 screws basically the assembly is complete. Yeah, just some more pictures also from the yeah, the jig and assembly team. On the left-hand side, this is kind of like a yeah, a machine they use for attaching the casters. You need to have a bit of force, so the casters can, the starbase can be just held in place, and then you can easily attach the casters without having to do it by hand, or, you know, it can be, if you're doing that all day, it can be quite painful. And some of the initial testing with product management and engineering for the upholstery. So just getting a sense of how the upholstery works, how it clips on, if it's easy to use, and yeah, just kind of like the final stages before launch. Yeah, and just a picture of the first 0 series. We didn't have red casters. These are just the protection for the casters when the chairs are sent out. And that's it. I guess that's the complete development of C Motion. You can see here the backrest on the table. That's actually the mono sandwich that I was telling you about. So you can see the different material types. So the dark materials are basically the ones filled with glass, and the light colored one, the white one, is basically the pure PP. And they're able to kind of control, yeah, exactly where it flows to get that kind of flexibility. Yeah, and I think Oya can share one more film from the upholstery. I think that would be quite interesting. So you should be able to see the Sedus logo, is that right? Okay, great. So the seats just basically clips on. And we developed these special kind of clips for the upholstery at the back. So they're quite big, and you don't have to really look for anything. You can just, yeah, with one click of the hand, you can basically attach the back. Yeah, very easy for the 3D knit. I think it's a bit more of a tight fit, so that there's no film of that, but it is a bit more challenging. But yeah, it's not that difficult if you think about, you do it maybe once a year or so. Yeah.
Okay, thank you very much, Carlo. That was an amazing story of so many people being involved and working nicely together to produce this little neat chair. So yeah, well done. And looks like we've done pretty good with time as well. So we still have some time, and you can ask questions to Carlo via the chat function. I have a quick question first, just saying, what happens to those chairs that you test so harshly? Are they still surviving after the test?
Yeah, it depends. I mean, some of them, it depends on which tests. I mean, some of the tests are more, yeah, forgiving, I would say. So you could continue using the chairs. Some of them do end up breaking, so they'll have to be sent for, you know, recycling, and then we have to also analyze what happens. Why did it break at that particular point? I know with the armrests of C Motion, that was quite tricky, because there's one test that kind of pushes them down and out. So, and it's done over a series of, I don't know how many cycles. I think it's something like 30,000 cycles. So, yeah, and with more weight than you would expect, it's as if somebody were to be sitting on the armrest rather than just using it. And in that case, yeah, there is some kind of deformation, but we actually came out quite well. One of the surprises we got was with the BIFMA test that we had to withstand. That wasn't a part of the deal at the beginning of the project, but management then decided to, they wanted to sell the chair also in the US. So that kind of came into the project later on, and actually when we're already finished with tooling. So this lower section of the mechanism, we had to shift that back a bit, which was a real challenge. You can imagine you're kind of adding material in the tool after the tool's been finished and all the testing's been done. So that wasn't a lot of fun, but yeah, that was one of the critical points that really broke. Yeah, when it wouldn't have caused the problem for the end user, but it would have yeah, made the chair not functioning anymore. It wouldn't have functioned like it should have. Yeah.
Thank you, Carlo. Questions are coming in. So here is a question from Alan Boyd. He says, any issue without having height adjustable arms?
That's a good question. For this particular project, we didn't want to have height adjustable arms to begin with. So we started out with just the simple arms because we wanted the side of the chair to be as open as possible. And when you have height adjustable arms, you have to move those further forward. I'm actually sitting on the second iteration of the C-Motion chair, and I can quickly share. You can see here that does have the height adjustable arms.
Yep.
But it's not as light, and it just makes the chair a bit more bulky, and there's just additional functionality. But yeah, it's a good point. To begin with, we didn't want that. But as an upgrade or the second stage of the development, we added height adjustable arms to the chair and a mesh back actually as originally planned. So yeah, we achieved, it was more or less a cost target to begin with. And also from a positioning standpoint, just the simplest chair. And then in order to fulfill some other requirements from the market, we ended up having height adjustable arms. Yeah.
Another question from Isaiah Walsh. How does 3D knitting work?
Yeah, that's a really good question. It's really, yeah, it's magical. I visited several facilities and saw how they work. It's difficult to explain. I can only say that I have another sample here, for example. This is from one of the suppliers that we worked with, and it was one of the first backs I did in 3D knit. So I don't know if you can see, you can control the amount of fill material within the back. And you can basically, during the knitting process, the knitting machine is putting in these garns, which are under pressure. So the garns are kind of like flat and are pretty much similar to the outer and inner layers, you could say. But then when that pressure is released, they kind of fluff up and create volume. So yeah, it's really amazing technology. Even having seen the machines, I can't explain more than that. That these fill materials, which are basically knit under a certain tension, and then once they're released, you're able to create a certain amount of volume. And also how you connect the two layers, so you're connecting the front and back layers together, creates these pockets. And so the material itself doesn't move around. You have to always have a connection between the two sides. Yeah.
Great. One more question here from Adam Barlow. Great presentation, inspiring. What was the development time and team size that delivered the chair? And can you talk about how this helped or limited the project?
Yeah, great question. So initially, an initial first week or two, working on the technical kind of concept, I would say we were pretty much all on board, all being like all three designers. So at Sedus, there were 3 in-house designers, and there were, I would say, 4 engineers, coming together to kind of think about this technical solution, which then we patented. And that was really important to have a mixture of like experience, but also some of the younger colleagues just throwing out some crazy ideas. So that was really important, I would say, at the beginning. But then after that, going into like the design phase, it was just myself, Klaus, and some of the upholstery, obviously, development, Peppo and Kurt downstairs. Obviously, other people were involved, but that was the core team. And I think having that core team just work very closely together and also having a direct link to management and being able to get decisions quickly really shaped or allowed this project to move really quickly. So I think, on the whole, just having a smaller team, once we had the solution in place, like a technical solution, was quite useful to be able to move fast. I hope I've answered the question completely.
I think you did. So another question from Daniela Martinez. You mentioned this was a quick process. Can you give us an idea of how long you had for this design development and how it compares to other designs you have developed? How did you deal with this? Did you leave anything out in the process of the process?
Okay. So all up, I think it was probably 1.5 years of developing and design development until we showed or presented the chair at Orgatech, and then it was a couple of months after Orgatech that the chair was available. So less than 2 years, and I think all up, 1.5 years within the development. I think now it's really fast, and compared to other projects that I've worked on, it definitely, I think it was the constellation, not the complexity. I think we were quite lucky at the beginning. If we hadn't have come up with this technical solution that wasn't patented, that gave us the right movement, we would have probably been struggling or searching for a longer time, which is the case with other projects I've worked on. I've worked on, as Oya mentioned at the beginning, the on-chair, for example, Wilkhahn, that was, I was involved for 3 years, but the engineers were involved, I think, for even 1.5 years before that, coming up with technical solutions. Chairs like Fern for Haworth, we were working on that chair for maybe 5 years. There's a different level of complexity maybe involved, but I think, it has to do with a bit of luck at the beginning, but also just trying to achieve the simplicity allowed us to focus on these main parts and not have to deal with other things within a task chair, like I don't know, lumbar adjustments and the height adjustable armrests, which came afterwards. So that definitely helped. I think it was, definitely a combination of the goal, but also having a bit of luck at the beginning to find such an elegant solution to begin with, because that's the trickiest part. And as I told you, the upholstery in this case was even trickier than the mechanism, which is not usually the case.
A few more questions for you. Christian Tietz, he's saying, great work, Carlo. Excellent to see all the steps and all the testing and collaboration required with engineers, tool makers, and manufacturers to make it happen. So there's not a question, it's just cheering you up.
Yeah, I think Christian was one of our professors at the time, wasn't he?
Yeah, he still is. He's here.
Excellent.
Yeah. And Mar has sent your award link. Here is Christian for the 2020.
Hi, Christian.
Good to see you.
Great to see you too. It's been a very long time.
Yes, has been too long. You should come over. The next question is from Özlem Er from Istanbul, and she asks, how does the process of competitor products analysis work in new product development, in deciding what kind of movement you want to provide that would be different than the competitor products, for instance?
Okay. Different from the competitor products. Well, there is a kind of a consensus that synchronized movement is really great. So I don't think we were trying to move away from a synchronized movement, because from an ergonomic standpoint, I think it's quite a comfortable movement for the majority of people. So what we tried to differentiate here was the amount of lifting in the seat. So compared to other chairs that we saw on the market, especially like weight activated mechanisms, which were still in a box kind of form, we wanted to first of all have it as part of the chair structure, but also make sure that there wasn't any kind of like pressure on the front of the legs. And another thing that was also in our minds, and which I didn't mention, but which is quite important, is also these kind of springs. They allow the seat to also flex forwards slightly. So you have a couple of degrees in kind of forward flex, which is also great if you don't like to sit towards the back. A lot of people like to sit towards the front when they're typing. It kind of gives you a bit of this kind of forward tilt position. So that was something that we also thought about in the development of this particular mechanism as a potential differentiator. But in general, I think there's kind of a consensus for a synchronized mechanism, but it doesn't have to be that. If you look at a lot of Scandinavian products, there are different kinds of movements which are also, you could say, ergonomic. Ergonomics in general, I think, is a tricky kind of topic. I don't think there's like the perfect chair. You really have to stay, moving, and now with the height adjustable desks being used more often, I think that's a great thing, because you really have to just keep on shifting your position. And having this kind of a recline is really useful to take pressure off your back and just to allow you to move. But in the end, you really should you should stand up and move around. So
that's the problem is us. We're not designed to sit.
Yeah.
So,
and obviously, one more part of the question was, but with patents, I think you have to obviously do your homework. So we work with patent attorneys, and we also do our research, and then make sure that we're not infringing on any patents at the beginning of the process. Not too far at the beginning, because then you kind of limit yourself. There are always ways around patents, you could say. It's just the way it is. But in this case, we tried to patent this as broadly as possible, because the idea that at that point was to use it for different chair versions. So it was kind of like the heart of the chair, which would be used for multiple generations. Yeah.
Thank you, Carlo. The next question comes from Turkmen Cansu from Italy. For the US market, do they prefer to send the complete product there, or simply shipping only the mechanism and making the production of the backrest locally there in order to cut down the shipping costs? Thank you.
I don't think they would build second tools in the US unless the volume was that large. So it wouldn't make sense. I think the backrest is also quite complicated. So you wouldn't just be able to, you could make a tool in the US. I don't think it would make sense though. Depends on volume, I would say. If the volumes are large enough, then they would create a separate set of tools, but I'm not really sure what the numbers are like right now in the US. So
next question is from Miles Park. He asks, you explained that when the backrest moves, the seat rocker tilts forward. Is this a unique approach? And how was this received by ergonomists?
It's unique in the sense that it rolls kind of backwards more than it goes up. But weight activated mechanisms are on the market. So, when we developed C Motion, there were other weight activated mechanisms, for example, in box forms that you could buy from suppliers. Some of them better than others, but I think in general, this particular mechanism differentiates itself in the sense that it doesn't cause too much pressure and doesn't lift you up as much as other mechanisms. as far as from ergonomists, I think it's pretty much a synchronized mechanism. And as long as you don't have any pressure points, like extreme pressure points, I think it's not a problem, especially for this class of chair. So we also have connections with ergonomists that we work with or worked with at Sedus, and they tested. But it's always with this kind of weight activated mechanism, it's always like a compromise. Obviously, you're not able to fulfill or you're not able to design it for every single person. Like I said at the beginning, if you for example have a larger upper body, then you have more of a lever, and so the mechanism will feel different in that particular case. But in general, it's a great approach for spaces where people don't adjust their chairs. So then I would say it's actually better than a fully adjustable chair. I've heard stories of people that bought chairs or were studying, for example, in Mannheim. One of my friends, he showed me their library, and they had some pretty cool chairs there. And he said, yeah, the only problem he has is that he can't recline. And I said, oh, it's just a click of a button. And he was studying there for 4 years and didn't know that you could actually unlock the chair. So that's a huge problem. Yeah.
The next question is from Tamyan, and she says, thank you for sharing so much insight. Now that the chair is complete, would there be something else you would do, consider, or add differently? And what was the most interesting thing you learned during this product development?
What would I do differently? I mean, there are a lot of small details, I think, that having had the time to kind of look at them and sit on the chair, maybe I would do slightly differently. But all in all, I think it came quite good together, like this balance between function and ergonomics and the design of the chair. Yeah, but there are certain details, like for example, the way the armrest covers clip on. We wanted to have that as easy as possible, but you do feel them on the underside of the arms, for example, and that's something that, I don't know, my fingers tend to go there all the time. So in the second version that we did, it's a different approach. But yeah, with the cost targets and different kind of goals, I think it was justified. Yeah, I learned a lot of things in this project. I mean, I've worked on mechanisms and task chairs, but I think, yeah, this particular chair, it was really just the simplicity, coming up with a mechanism basically out of such limited, just a limited amount of material, and also having it perform really as you expected. I think that was one of the biggest challenges, and I was kind of skeptical at the beginning, but working together with the team, I think that was yeah, especially Klaus. I think we were able to achieve that. And upholstery, like I've said it a couple of times, but yeah, that was super tricky, getting the upholstery to work, that it looks good, but also functions and as it should, that it's also easy to repair. All these things coming together, and then you have all these different fabrics that you have to consider as well, and different stiffness, and it really is a big challenge coming up with an upholstery solution, especially when it's something that is not just fixed on the chair. So I think those two things were really a big learning. I learned a lot during that development.
So I think the last question comes from Alan Boyd, but he has a comment too. He says, well done, a lovely, well-designed, simple chair. And his question is, when does the environmental considerations come in your design process?
Well, yeah, I think it should start from the beginning of the process. So making components out of, single materials, if possible, thinking about the different impacts that different materials have. In this case, not combining different materials that cannot be recycled. So at the back, they're both polypropylene, so you could recycle them. And in general, I think there's a lot of like the trend towards like more natural materials, wood, bioplastics, but having functional plastics, I think, is still very important, especially if you consider the lifespan of a product. If you're able to think about longevity, and in this case, also being able to exchange the upholstery, the hard-wearing parts, and being able to use the chair for a longer period of time, you're able to kind of, get the most out of it. But yeah, at the beginning of a project, you really consider what materials, what technologies, and where or what possibility they have for recycling, and if not, you know, what is the outcome compared to other materials. And then you can do a life cycle analysis, which is sometimes really tricky because depending on which one you use, you get a different number. So you have to maybe do several, or just also use your intuition. For example, with special special plastics like glass reinforced plastics, you can recycle them, but you really need large batches. So I think it's not only the materials that you use, but also the infrastructure and the whole kind of system you have in place. And I think here there's a lot of work to be done in the furniture industry, like really working to collaborate and to get back a lot of these important materials and recycle them, because on paper you can recycle everything, but the infrastructure is just not there to do it in the way that you would hope. So yeah, I think there's a lot of work still to be done in that sense, communication and infrastructure.
One last question from Teresa Nidiri. Well done designing and creating the C motion. Would the upholstery be machine washable with the clips in place?
Yes, I have washed the back of this. The back can be washed with the clips, but the seat is a bit more tricky. I think the seat, you would have to either have it professionally cleaned, or you would have to replace it. It's unfortunately not the best solution. Yeah, but it was the one that kind of allowed for the longest possible use. So it's always a balance, you know. On the one hand, do you allow users to take it off and easily? But then on the other hand, you know, it wasn't functioning as it should. So yeah. So for the backrest, yes. For the seat, professionally cleaned or replaced. Yeah.
Okay, thank you so much, Carlo. We came to the end of our time. And we want to extend a heartfelt thank you to you for presenting this amazing story and sharing so much of it generously with us. So thank you. And again, big applause. That was really interesting for me to watch. And to all our attendees, again, thank you for joining us and making the evening even more special with your presence. But before we end the session, I want to mention the next talk scheduled in 3 weeks for November 7, where Greg Abstone from Breville will present our stories behind products, number 8. So Greg is also an alum of the industrial design program at UNSW, and he will tell us the story of the HydroPo Pro Plus immersion circulator for sous vide cooking. So stay tuned for the invitations. And we look forward to seeing all of you again to our next stories behind products. Until then, be safe and well. Goodbye.